We've looked at several ways of examining the variation in a data set. We've looked at range, we've looked at the 5-number summary, and then using a visual of the 5-number summary with a box plot. In this video, we're going to look at another measure called the standard deviation. The standard deviation is another calculation for variation or the spread that we see in the data. And the standard deviation is very commonly used by statisticians. One way to understand what this measurement is that it can be described as the average distance between each data point and the mean. You'll notice that I put average in quotes because it's not exactly what we would think of as the mean or the average distance, but it's really close, and that's probably the best way to understand it. Now, calculating the standard deviation by hand is not an insignificant enterprise. It takes some time. So we're going to do it a couple of times, but I'm also going to show you how to do it with technology. So let's do it by hand first to just get a sense of what we mean by the standard deviation, understand that average distance idea. So the first thing we need to do when calculating the standard deviation, and we need to compute the mean for the data set. Because what we're going to do is we're going to be looking at the average distance between each data set and the mean, so we need to know what the mean is. So if we wanted to find the mean, we would take our data values, which I have listed in this table, and these may look familiar because we used them when we were looking at the 5-number summary. These are hold times in minutes for phone company A. So we would take all of these data values and we would add them up and divide by how many there are. Well, there's 9 values. So when we add them up, 24 plus 25 plus 25 plus 26 plus 27 plus 27 plus 28 plus 29 plus 30, we actually do get a total of 241. And we would divide that by how many there are, which is 9. And we do get a decimal that continues off the screen of your calculator. We're going to round that at the first decimal place. That's the general rule for means. So I'm going to round that 26.77777 becomes 26.8. So that's rounded. Just going to make our life a little easier. Next, what we're going to do is we're going to find the distance between each data point and that value of the mean. Okay, so a table, which is why I have a table set up here, can really help you organize this information when you're calculating standard deviation. So what we're going to do is take each data point and we're going to subtract 26.8 to find the distance between the data point and the mean. Normally we wouldn't write minus 26.8, but I wanted to emphasize that's what I'm doing. So when I do that, 24 minus 26.8, I do get a negative because the mean is higher than the data point. So when I subtract a larger number from some smaller number, I get a negative. So I get negative 0.28. And I'm going to continue to subtract 26.8, the mean, from each of these data points. If I subtract it from 25, I will get negative 1.8. If I subtract, again, 25 would be the same value. 26 would be negative 0.8 because I'm getting closer to the mean, so my distance has gone down. It's a little bit smaller. Then we have 27 minus 26.8 because now our data point is higher than the mean. We're going to get a positive, so 0.2. Another 27 is another distance of 0.2. 28 minus 26.8 would be 1.2. 29 subtracted 26.8 would be 2.2. And when we do the last data value of 30, we would get 3.2. So what we've done is we found the distance between each data point and the mean. And some of those distances are negative, some of those distances are positive, because it just depends on which side of the mean the data point was on. Now at this point, if we were really calculating a strict average, we would add up all of these distances and divide by how many there are. But the problem with adding them up right now is some are negative, some are positive, and the negatives are going to kind of undo some of the positives when we add them up. So we don't want that to happen. We want to actually be able to look at these distances. So what we're going to need to do is somehow eliminate that negative so that everything that we're adding up is the same sign. There are a couple of ways you can eliminate the negative. One is you could take the absolute value, which is often how we think about distances. But for standard deviation, statisticians, mathematicians came up with the idea of squaring these distances, because when you square a negative, you will get a positive. So we're going to square each of these distances in the next part of this calculation. And this is how the standard deviation is defined. So we're going to square these distances. So negative 2.8 squared would be positive 7.84. And because we know it's going to be positive, when I throw that into the calculator, I don't even worry about putting the negative in. I just take 2.8 and square it. Likewise, 1.8 squared is 3.24. We know that all of these squared values are going to give us a positive. Now, one thing I want you to be really careful about, this is a square. Squared means the number times itself. Often we would represent that if the number is x, we would represent it as x squared. Do not square root. Sometimes people will accidentally use the square root. That is not what we're doing here. We are squaring. We're multiplying the number by itself because that removes the negative. All right, continuing on, 1.8 squared is again 3.24. 0.8 squared is 0.64. 0.2 squared is 0.04. Again, 0.04 since we have the repeat of a value. 1.2 squared is 1.44. 2.2 squared is 4.84. And 3.2 squared is 10.24. So you can see how the table kind of helps you organize this, because there's a lot of individual calculations related to individual points. So the table kind of helps you organize. And the last thing that's really helpful about the table is that we're now going to add up all of those distances. And this is where the average idea comes back into play. We've now removed the negatives, so we're going to add them all up and then divide by how many there are. So when we add these all up, and because I've got them in this nice column, I can total up that column. I get 31.52. I'm going to take that square distance, and the fifth step is to take this and we're going to divide by how many data points there are, with a slight adjustment. Remember I said this isn't quite the average. I've got average in quotes. We're going to divide, instead of by 9, we're going to divide by 1 less than the total number of data points. So if the total number is n, we're going to divide by n minus 1. So I take that 31.52, and again, I don't divide by 9, I divide by 1 less than 9. So technically I'm dividing by 8. So 31.52 divided by 8. And this is how, again, this is an adjustment that mathematicians have done because we're kind of adjusting things a little bit differently by doing that square. And what they found is that if you're dealing with the squared, it's better to actually not divide by the total number, but by 1 less than the total number. So when I do that, 31.52 divided by 8, I get 3.94. All right, so we're almost done. The last step is we're going to square root this number. Now, why are we going to square root it? Well, because if you think about what we're doing, we're trying to find an estimate of the average distance of each data point to the mean. And right now we're finding the average squared distance. So to undo the square, which I purposely put in to get rid of the negatives, I need to undo the square by the square rooting. So this is where the square root comes in. I actually am going to square root this number. So when we square root that number, I'm going to actually get the standard deviation. We spelled deviation, standard deviation right. So the standard deviation will actually be this final value I get when I square root 3.94. And that will be, again, this net decimal is going to go across the screen, and I'll just round it off several decimal points here, 1.985. I rounded at the third decimal point. So the standard deviation, in fact, if I just round it to the nearest whole number briefly to make it easier to talk about, this is approximately 2. So the standard deviation here is saying that if you were to look at each data point, on average, they are 2 units away from the mean. And you can think of the mean as kind of like being in the middle of the data set, someplace in here. So each data point is on average, an average distance of about 2 units from the original mean. So if we think about what this represents, hold times in minutes for this company, the mean hold time was 26.8 minutes. On average, when you look at all of the different hold times, the different hold times are on average about 2 minutes away from that middle mean or value that we had.